In lesson 2, we're going to look at more graphs with exponential functions, but the difference for this lesson is we're going to look at, instead of just any number base, we're going to look at functions that have a base of the number e. The number e is the natural base, or it's the Euler number. And it's kind of like, you can kind of think of it as, it's like a special number, kind of like pi. It's irrational, and it's approximated to be 2.71828, and so on. Your calculator does have an e button. Typically, it'll have like e to the x. So it might look like this in the calculator. Like a little x. So that's how you would get it. So if you wanted to put in these examples here, if you wanted to find e just in general, you would put e to the 1 in your calculator, and that's how you would get the 2.71, so on. So in your calculator, look for the e button, and if you were to put this in your calculator, you would do e caret 3.2, and when you do that, you should get 24.533. So just check that to see if you're getting that. And I am rounding to the nearest thousandth, so I'm just doing 3 decimals. This one, you're going to include the negative, so e to the negative 1.6. So when you round, you should get 0.202. And then the last one here, we should get 1.008. So just try those, make sure that you actually get those numbers, just because we're going to be using it, and you want to make sure that you're getting the right numbers. On this one, we're going to simplify without a calculator, so we're going to use the exponent rules. So e is your base. It's not a variable. It's a number. So it's kind of like if you had 2 raised to the 2 to the third. You could put this in your calculator and get a value, but what we're going to do is we're going to leave it as an exact value, which means I'm not going to actually do anything with e in the calculator. So whenever you raise an exponent to an exponent, you multiply the exponents. That's the rule. So it's just going to be e to the 6th. And then whenever you divide, same base as with exponents, you subtract these. So it's going to be e, keep the base, and subtract, you get 2. So that's kind of just giving you a little information about the number e. The next thing is we're going to look at the graphs with e. So these are still exponential functions. The difference is instead of having any number, we're having e as the base. So when it's just e to the x, it's going to represent growth. It's going to be going up. And when it's e to the negative x, it's going to be our decay function. So it's going to be represented a little bit differently. Instead of having your, thinking about the last unit, when b was between 0 and 1, it's decay. And when b is greater than 1, it's growth. In this case, we're looking at the exponents, because really what this is saying is y equals 1 over e to the x. So that's what makes this decay, because it's really 1 over e is the rate. So let's go ahead and graph these. So we're going to create a table. So for this one, I'm just going to do like -2, -1, 0, 1, and 2, just so I get like a symmetric amount of points here. And then we're going to just plug in. So e to the -2 in the calculator, I'm going to just round 2 decimals. E to the -1 will be 0.37. E to the 0 is just always going to be 1. E to the 1, 2.72 if I round that. And then 7.39. So I'm just plugging these right in for x into y equals e to the x. Then we plot these, so we have -2.14. 1 is up 2.7, and 2 is up 7.39. And again, it's going to get really, really close to 0, but it won't actually touch 0. So it should kind of have that rounded curve like an exponential function. Oops, I just shifted this. So this is going to be y equals e to the x. So it looks just like an exponential growth function, which it really is, because it's really the same thing as saying y equals 2.71828 and so on raised to the x. So it's very similar to an exponential growth function of y equals 2 to the x, and y equals 3 to the x is in between there. So then decay, we're going to do the same thing, except for this one I expect to be going downward. So I'm going to just do -2 again till 2. So I have 7.39, 2.72, 1.37, and 0.4. If you notice, these are flipped because here I had a negative, here I had a positive, so they flip. So we have -2 up to 7.39, -1, 2.7, so again, when you draw this, you're trying to sketch this so that it gets really close to the x-axis, but it doesn't actually touch it. So I'm just going to label my axes. So this would be y equals e to the -x. So again, the asymptote for both of these is y equals 0. And it's going to work just like an exponential function where if we add something to the end, that's going to be the asymptote. So this will never cross the line y equals 0 or the x-axis. It'll always just get really close to it. Same with the growth function. So let's look at shifting these. So if we do transformations with these. So it's going to work the exact same way. We're going to have some number times e to the x minus h plus k. Our parent function, instead of having b involved, which if you remember, b was our base or our growth rate, we have e, because if we're talking about an exponential function with base e is always going to be the base. So the a is going to be the number that's going to change, and we're going to include that in our parent function because we don't want to have to worry about trying to multiply and thinking of it as a vertical stretch or shrink. So the easiest thing is just to keep a with the parent function, and then from there we'll do the translation. So we're going to always translate using the h and the k value, and h is always going to be the opposite of what you think. That's going to be the horizontal, so it's the HIVO again. Horizontal is the inside, so it's inside of the function, inside with the x. K is on the outside, so that's going to be the vertical, and k is always what you think. So based on this, a minus h really means right h, and plus k means up k. So when you pull these out, notice how h becomes positive. From here it was negative, so it's always the opposite. And k it keeps the same sign. So these basically, whatever numbers are here, are actually the direction that you move. So if they're both positive here, coming from a negative and a positive, that means we're going right and up. And again, the asymptote is always whatever that number is at the end. So it's always going to be y equals k. Because that's your vertical shift, so it's how much it's moving up or down is where the asymptote's going to go. So when I look at this one, the first thing we're going to do is come up with the parent function. And remember, we're going to keep that 2 in front as part of our parent function. So y equals 2 e to the x. And then we're going to do our graph for that. Again, I'm just going to go -2, -1, 0, 1, and 2 just to get enough points. I'm going to round 2 decimal places when I put these in my calculator. So I just get all of those from my calculator just by plugging in x into this equation. And then I go ahead and I plot these. And the 14 is going to be up here somewhere, so I'm just going to know that my graph is going to keep on going. And again, it's going to kind of flatten out. And it's going to go on forever. I'm going to label my axes. So my asymptote of this graph is y equals 0 because it's our parent function. And now I'm going to look at the translation portion of this. So the translation we have the horizontal is +2, so we do the opposite of that, so it's going to be left 2. And then -5, we do the same, that's our vertical, so we're going to go down 5. So I'm going to take each of these key points that I just plotted, I'm going to move them left 2, down 5. 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. And then we know that it's just going to keep on increasing upward, leveling out down here. And my horizontal, or my asymptote is going to be down here at -5, because remember, whatever that number is at the end, that's your asymptote. So y equals -5 is the asymptote. Your graph will never cross that. And then my actual graph, I'm just going to label tempting to label +2 -5. And then one last thing, just to say the domain and range of my actual graph that I wanted. So my graph that has a translation done to it. So notice it's going to go left to right forever. There's arrows. It's going to keep going left. It's going to keep growing wider and wider as it travels upward. And then the range, the smallest value it'll ever get is really, really close to -5, but it won't actually touch -5. So it's going to be an open bracket at -5 up to infinity. So that's it. So it's really basically the same idea. The only difference is you have a base E instead of just a number. And remember, E is a number. There's a button for it in your calculator. So always make sure you're using the button though, and not just approximating it to be 2.71. And that's it.